Hello students. Today we will discuss about interpolation, one of the important part of numerical methods or analysis. So first we will discuss about what is interpolation, what are the different methods of interpolation, and at the end we will discuss about some of the numerical problems related to interpolation. So what is interpolation first? So interpolation is a type of estimation, a method of constructing new data points based on the range of a discrete set of known data points. So the example is, you can take a function, a simple example you can take. So x is the variable for which you are getting the function value. So if you get this value, so say these are the given values x1, x2, x3 up to x6. So for that corresponding function value is known. So what will be the nature? You can easily plot this one. But if the number of data is very large, so every time you really cannot construct this nature of this curve. But sometime you need to get a information, say somewhere here. So it's in between x5 and x6. Or say you need a data information about, say, this particular point. So how are you going to get this thing? So if the number of point is very less, so you can plot the curve and you can get those data. But if the number is very large, so the given set of data is very large, say 10 to the power 10 number of data are there. So how are you going to find the information of this particular point? So to do these things, we used to use the concept of interpolation. So what we are going to do? So there are two methods of doing this thing. Either you can plot the curve, you can get the nature of the curve, or you can write the equation of this curve and you can get the function value. Or directly for a particular function, you can get this thing. So first, and one of the important interpolation is Newton's interpolation. So there are three types of interpolation. Newton's interpolation, one is forward interpolation, the second one is backward interpolation, and third one is central difference operator interpolation. So forward difference operator interpolation, backward difference operator interpolation, and central difference operator interpolation. But in this section we will talk about forward and backward interpolation. So what is the concept over there? So you need to get the function, and we are assuming the given set of values are equal spaced. Okay, so here you can use this thing. So take the graph again. So this x1 and x2, they are of equal space. x2 and x3, x4 and x5, they are of equal space. So it start with, say, x1, or you may start with x0. What are the given values are there, and they are incremented by plus of h. So h is the step size. So for each and every given value, you have the function value. So what we are going to do from this given value? So we are going to find the difference between all the given function values. So the function we are just writing, say, f of x0. So this is represented at y0, f of x1, this is y1, f of xn, this is as yn. And we are going to use this particular formula to find the difference. That's why the name is the difference operator. So this is the symbol of an operator. So when you write this one, so it's the operator, difference operator. This is known as a forward difference operator, or is acting over this function. So what is the operation, the mode of operation? The mode of operation is f of x plus h minus f of x. So if you want to find this thing for y0, so what is the function value? So you are just finding delta f of x0. Okay, so there is a difference between f of x0 and delta f of x0. So f of x0 is the y0, so the first given value. But now we are finding delta f of x0. What is delta f of x0? Delta f of x0 is function x0, the given value, plus h minus f of x0. So what is f of x0? This is y0. And what is x0 plus h? So x0 plus h is x1. So this is basically f of x1 minus f of x0. So you can write this as f of x1 minus f of x0. So this can also be written as y1 minus y0. So this can be delta f of x0 or delta y0. So you can also write it for delta y1. So same concept. This will be incremented by 1, delta y2 up to delta yn minus 1. So we have this particular relation. Okay. Now after having the first set of difference, we can go for second set of second order differences. So what will be the second order differences? Now after having the first set of values, so you have the difference between them. Now the second set of value, now we are going to find the difference between the differences. Difference between the differences. Just look at this particular relation. I'm going to rub this one. So now you have delta y0, this is y1 minus y0. Good thing. Okay, you have this one. Now you're going to get it for the second order. Delta, it's a first order. Now we are trying to get it for the second order. The second order, the thing is now the delta operator will be the second order. Now you are find the difference delta y1 minus delta y0. Okay, so you can get it up to n minus 1 this time. Now you can get it for delta 3. Now the operation will be over delta 2 of earlier and the delta minus delta 2 the next one. You can also get delta 4, delta 5 up to delta n. Any generalized order you can find it. So this is the way how we can get that Newton forward interpolation. But how to do it? So to take that one, we are going to refer this particular table. This is known as the forward difference table. Now in one column, the first column, you have the say x values, the variable values, this is the function value. So x0, y0, x1, y1 up to x5, y5 or xn, yn value is given. Now we're going to find the differences. We're going to find the differences as y1 minus y0. So whatever we have referred, okay, this is y1 minus y0. Same way, you will get y2 minus y1. So this will give you delta. So the difference between these two, we can just think about this difference will give you this. Take the different color. So we'll have this minus this. So the y2 minus y1, this will give you this one. Okay, so you can go for the others one also. So this is the first difference, the first order difference. Now think about the second order. So second order, what we're going to do? Second order, this will be delta y1 minus delta y0. You have the difference. Delta y2 minus delta y1, you have that second. If you want to get it for the third one, so obviously you're going to find the difference between these two. Delta 2y1 minus delta 2y0. Okay, you can get that one. Okay, if you want to get it for the delta 4, so the fourth order, so this will be delta 3y1 minus delta 3y0. You have this one. Okay, now we'll have the delta 5 up to this one. So as we have the 5 set of data, so we'll end up with a delta 5, the fifth order forward difference operator. So if we go for that higher order, say nth order, obviously you will get that nth order delta n. Why? That the method will be similar. Now you have the set of values. Now we can just think about we are talking about the forward difference, so we're going to consider the upper one. Okay, so we'll have this and we're going to consider this one. Now when you have this particular thing, now we'll be able to write the equation for this. So what will be the equation? We really don't know the equation. We have a set of data and we are able to find the differences. Now we're going to write the equation for this. So the equation yx, it can be written as y0. Now the first value is y0. You get that one. Okay. Then the second one will be delta y0. You have delta y0 in this part. But this will be multiplied by p. Now what is p? P is x minus x0 divided by h. So x0 is known. So what is x? See, if you want to find a value somewhere here in between x0 and x1 or x1 and x2, you're going to consider some value. Say this is x1 dash, some value somewhere here. So this is basically x. So you're going to find x minus x0 divided by h. Now you know what is h? H is the step size. So you'll be able to calculate what is p. So put the value of p, put the value of delta y0. Then in the next term, the third term will be p into p minus 1 whole divided by 2 factorial. 1 into 2. 2 factorial is 1 into 2. Then this will be for second order. Okay. So you can write it for the third order, you can write it for the fourth order up to nth order. So what will be there in the nth order? P into p minus 1 into p minus 2 up to p minus n minus 1. Okay. So whole divided by n factorial. And the nth order difference, nth order forward difference. Now you know how to calculate p. how to calculate the forward difference operators. Now when you have all these things, you can put this thing in this equation, you will get the equation from this. Okay, so you will get the desired equation what you are looking for. So how the set of data is represented in form of function, you can easily get this thing. So this is known as the forward difference method. Now the next one is the backward difference. So the concept of forward difference and backward difference, they are similar. Okay, so only difference is in earlier case we have just moved from upward direction. So from the upper part we have considered the upward part. Now here we are going to consider the lower part of this thing. So as we are considering the lower part, obviously you will moving in the opposite direction. So signs will be different. Let me just check it. The concept of function and the variable, they are similar. x0, x1, x2, xn up to this one, you will get the function value. Now the operator will be in the inverse order, reverse order. Now see, earlier one operator was something like this. This is the forward difference operator. Now this is the backward difference operator. Okay, so sometimes this is known as delta, and this is known as nebula. The delta operator or nebula operator. So this is a forward difference operator and this is the backward difference operator. But the process is same. One is moving from the upward to downward and another is moving from the downward to upward. Now see, here the differences is given as, so delta y1 is y1 minus y0, sorry, this will be y0, this will be y0, so you have done a mistake, this will be y0, this will be y0, yes, sorry. Then you will get the delta y1, this is y2 minus y1, y2 will also, you will get this one. Then again when you have the first order, you will get the second order, delta y0, okay. So you can go for up to the nth order, okay. So you will get the differences, how to get that one. Now see the tables, same concept, you have your x, you have your y, now you are going to find the difference, okay. So you are going to get this one. Now in this particular equation, we are going to consider the lower part of this. So the lower part means this particular section we will consider. Okay. So here yx, this is yn, that means in this case is the fifth one. Okay. So delta y4, this will be delta y4, so the first one, first difference, first order difference. Okay. This will be the second order difference, this will be the third order difference up to nth order difference. So the only difference between backward and the forward is, so here in this case we are going to consider the lower part of this one, okay, and we are going to consider, we are going to rewrite that equation. So in this case, now see p and u, they are similar, x minus xn divided by h. So in case of p also x minus x0, so the p was considered as x minus x0 divided by h, okay, but in this case this is written as x minus xn divided by h. So what is the difference? So we have just mentioned this thing, that in case of forward difference, if values are in the upper range, so we are going to consider the forward difference. But in the backward difference, if the values are somewhere here, so if you want to find x4 dash, which is in between x4 and x5, so it's better to use the backward difference. So you can use the forward difference, but there will be chances of error. But if you are considering the backward difference in this case, okay, so you will have a higher chances of better result. So you will get that one u, x minus xn divided by h, put this back in this formula. Just remember, in case of forward difference, this was minus, but here these are plus, okay. So yn and also forward difference is to start with y0, delta y0, but this is in the reverse order, so this will be given as yn plus u delta yn. So first order backward difference operator, okay, u into u plus 1 divided by 2 factorial. Second order backward difference operator y0, so you can go for the third order. So third order means u into u plus 1 into u plus 2 divided by the 3 factorial, okay. So you will get the third order backward operator. Then up to go for, you can go for up to nth order, okay. So this is the difference between backward and forward difference. So you can use a set of data and you can predict some of the values within the range of this thing. These are the important relation properties of those operators, okay. So this is applicable for both forward and backward operators. So only the difference will be in the forward difference. So if you are operating over x, okay, so now here this will be x plus h minus of fx. Okay, so you just remember this one what we have written. But if you have the nabla one, nabla of fx, now the same thing will be in the reverse order, because this will be x into minus x minus h. Okay, so you can just think about a axis where you have that x value here. So here you will have x plus h, and somewhere here you have x minus h. So when you have forward difference, you will go to consider this minus this, and the backward is x minus this one. So this. So let me just check it. So it's just a continuation where a and b, they are constant. So these f and g, they are functions. So simply a will be taken as constant, and this will be operated over this function. Okay, so you can just check this one. So simply this will be operated only over those functions. These are constant values. Now you have a and g, both functions are there. So how they will act as? So this will be f of x plus h into delta gx. So now we can write it delta gx. Now you know what is delta gx? This is gx plus h minus gx. Okay, and this will be written as gx plus h into delta fx. So now you know what is delta fx. Put these things and you can calculate this. So if you are talking about the orders, so if you have two different orders simultaneously working with this m and n, so this will be simply added over this one. So that order will be m plus n. Now if you have the division, so earlier cases were the multiplication, so here they will have the division. So if you have division, so this will be gx minus delta fx minus fx delta gx divided by gx plus h into fx. Okay, so these are the important formulas for the operator. Just remember, which will going to help you for solving numerical problems. Now we'll check how to solve the numerical problems by using, or how to get the polynomial, or how to predict the values by using the Newton's forward and backward method. So the first we're going to take a problem where x values and y values are given. Say it's a simple example of a certain year. So from 1891 to 1931. Okay, some values are given, some populace around something is given over there. Okay, now it is expected that you will go to calculate the value of the function at x is equal to 1895. So you don't have the value of 1895, you have the value of 1891 and 1901 with a gap of 10 years. But you need to predict a value which is somewhere here in between these two. So how are you going to do these things? So we're going to use the method of Newton forward method. Obviously it's in the upper part of this one, so we're going to use the forward method. Okay, so the techniques are simple. X and y, right, that x and y, get the values of delta y, okay, delta 2y, delta 3y, delta 4y. It ends at delta 4. So now you can see the differences: 66 minus 46, 81 minus 66, and you have the set of values for the delta y. So what is delta 2? Now again, this is 20 minus 15. So you'll have the differences. Sorry, this will be 15 minus 20. 15 minus 20, this will be equal to 5. So minus 5 term will be there. It missed it anyway. Okay, so then again 12 minus 15, this will be minus 3. 8 minus 12. So now in the forward difference, what you're going to do, we're going to find the difference from the lower part to upper part. Just remember this one. This will move from this minus this. So you can see the differences. Okay, so minus 3 minus minus 5, minus 4 minus minus 5, you have this. Now what you have? Now you have the values for this particular part. So you have y0, delta y0, and the upper parts. Now what we're going to do, we're going to put this thing in the formula and you can predict what is the value. What we're going to do? Now see, just you have taken. Okay, so first you need to calculate what is h. H is this minus this. Okay, so this will give you the value of h. So this value is given there. So you have equally incremented of 10. Okay, just remember the forward difference will only be implicable or only applicable where the step size are equal. If the step size are uneven, you really cannot use this thing. So the step size calculation is very, very important. Now you need to calculate what is P. So x minus x0. So you know the first value x0, and what you are going to consider x as 1895. So you need to get that value. X minus x0 divided by h. These values are already calculated. Put this back in this equation. Now x is 1895. So you are calculating P with respect to 1895. Put it back and you will be able to calculate this one. So the calculated value source, which is around 55. So 54.8. So your predicted value around 1895 is 54.85. So this is the process by which one can calculate forward difference. Now check the second one. So we are trying to calculate it for the same problem we have taken, and we are trying to predict the value for 1925. So where is 1925? It's at the end, somewhere here. It's 1921 and in between 1931. So somewhere here it's 1925. So the same method. So we're going to draw the table and we're going to put this thing in the formula and we'll calculate this. So the only difference is, now here the calculation will move from this minus this. Okay. So get that one, get that values. Get this one, get the differences. Get the differences. Now what we're going to consider, the bold section will be considered. We're going to consider these values because we are trying to use the backward difference method. Put this thing in the formula. Put this thing in the formula. So get the y. Oh, sorry. This will be p. Sorry. This will be u. So what the formula we have used, this will be p, u. So you can also write it p also. But this is u. So what is u? We are calculating x minus xn divided by h. So this is 1925 minus 1935. Now see, these are the positive values. These are the p u into u plus 1, u into u plus 1, u into u plus 1, u plus 2. So the formulas are known. Okay, sorry, I've done a mistake also. This will be n. These are n. Okay, these are n. Put this thing in the formula and you will be able to calculate the thing. So it comes that in 1925 values are almost 96.8. It's approximately 97. So here we have discussed about two important methods of interpolation. So in this interpolation, we have first we have talked about the operators. Okay, so how to get the operators of higher order and how to write the equation, okay, by using this operator. And then from that we are able to predict the values of this thing. So we have discussed about the forward difference and also we have discussed about the backward difference by using the tables.